All right, guys, so this is notes for 17.4. This will go real quick. This is called solubility products. Solubility meaning, of course, a solid dissolving in the medium is going to always be water for us. Now, if we're going to dissolve a solid, then you're going to notice that you're going to see the solid, only the solid on one side. That's because you may actually see something like plus H2O, because that obviously happens. But this is a net ionic equation, so we don't even need to show the water and what happens over here. So notice that we have a solid. You guys know that for equilibrium, that if we have a solid, it is the concentration of the solid or the pure liquid is always 1, so it doesn't even show up. Now, this is going to be specifically called KSP. Now, this would typically go on the bottom of our fraction like this, but because the bottom will have a 1, we won't even be doing that. We'll just be talking about, I love it when it does this, I really do. There we go. So we'll just be talking about the concentration of the Ba with a plus 2, and over here the SO4 with a minus 2, and because these two are a 1 and a 1, there are no superscripts or exponents that go with that. So this is going to be one of the easier types of different types of equilibrium. The KSP, the S stands for solubility, and the P stands for products, the solubility product. So this is the equilibrium constant for finding out how much things dissolve in water. At a standard temperature is usually 25 degrees Celsius. So it says the same thing that I just put down there. It says where the equilibrium constant KSP is a solubility product. There's literally one more slide, so this is going to go very quickly. KSP is not the same as solubility. Solubility can change drastically with common ions, with pH, with a whole bunch of different things. So KSP is a lot more stable, and it talks about the KSP of a whole bunch of different types of compounds at one temperature. So that KSP wouldn't change if you threw a common ion in there, if you change the pH. Like all those different things would affect solubility, but not the KSP. So that's one thing you definitely should know. Solubility is different than the KSP. The KSP is the constant from the solubility system, of which we just showed you the last slide. Solubility is generally expressed in mass of solute dissolved in 1 liter. So that'll be grams per liter or milliliters, grams per milliliter of a solution. It really depends. So in also moles per liter, but what is that? That's concentration. So take a look at what we have here. We have KSP all the way down at the end. You can go from KSP, you can figure out what molar concentration is. Molar concentration would, of course, be this one. And, of course, that one. And then solubility would be the one all the way at the left-hand side. Like that is literally it. And going in between these, it would be the same way that you'd go in between grams and moles, because these are all ending or over liters or over volume. So going between grams and moles would, of course, be an atomic mass conversion. So, and I'm going to show you examples of all of that. So that's it. I'm not trying to draw this out. That's the last one. The next part of this is factors affecting solubility. The first one's common ion effect, and after that's pH, and then after that is some other stuff with forming complex ions, which we're not going to really talk about. This goes a little bit deeper than we need to. So that's it. I'm done. 17.4. Thanks for paying attention.